recording?
Yes. Hey everybody, welcome to section 4.1. Full disclosure, I have a bit of a cold, so I'm not sure I'm going to be able to make it through all the videos this week. And if that is the case, then we'll just use the old lecture videos to augment. But let's get started. So section 4.1 is about exponential functions. It's actually not calculus. This is actually algebra. So just to review a couple things, the function b to the x is called an exponential function, and it's got a base b. And I think most of these, instead of saying them out loud, you could pause the video and look through them and make sure you remember them. And I'll start with number 1. Write each as a product. So it says 4x in parentheses to the third power. A power of 3 means that you multiply it by itself 3 times. Like that. So part B, negative 2y to the fifth, z squared. A fifth power means the base multiplied by itself 5 times. A square is the base multiplied by itself 2 times. So negative 2y times y times y times y times y, and then times z times z. Negative 10 to the fourth, that's just negative 10 times negative 10 times negative 10 times negative 10. Simplify each expression. All right, so 14 cubed times 14 to the fifth. There's a rule up here that says, let's see if I can find it. If you have two things that are the same base and both to a power, you can just add the powers. So that one would be 14, 5, 6, 7, 8 to the 8th power. And then x to the third times x to the first power. I can also combine powers. That would be 3, 4. And then 14 times 8 is something you could put into a calculator. Let's see. 14. Oh, actually I don't have a power button, so you have to do it like by hand. 14. So I'm just repeatedly multiplying by 14 8 times in my calculator. 1, 2, 3, okay. Which you can't see on screen, which is kind of funny. 2, 3 times 14. Okay, so it's a very, very large number. 1, 4, 7, 5, 7, 8, 9, 0, 5, 6. Okay, it is 1,479 of 75. Very, very big number. X to the fourth. Okay, part B. So I have a y to the fifth power and a y squared. And an x to the third over an x. So 48, I think I can divide that by 4. Let's see what I get. 48 divided by 4 is 12. Excellent. And then using the rule here, let's see, where is the rule I'm thinking? This rule here, so I have two bases that are the same, one on top and one on bottom. I can just use subtraction. So 3 minus the power of 1 is just x squared. And y to the fifth over y squared, that'll just be y to the third. Part C, so I'm multiplying it by itself 3 times. I could do that, or I could use this rule right here. So actually I should probably erase all these, but I have a rule that says if I have some parentheses to the third power, I can just do each thing to the third power. So negative 4 to the third power times a to the fourth, also to the third power, times b squared to the third power. So negative 4 times negative 4 is 16 times another negative 4. Let's see, 64. Negative 64 And then a to the fourth to the third power, I'm going to multiply exponents. 4 times 3 is 12, a to the 12th. B to the second power to the third power, that would be b to the 6th. Okay, and then for D, so actually I think we're done with that one. All right, so actually this is very nice. So I've got x to the 12th divided by x to the 9th, so I can just subtract. 12 minus 9 is 3. And then I have y to the 5th over y to the 9th. So again, with subtraction, 5 minus 9 is minus 4. And you could leave it that way, but you could also write it as x to the 3rd over y to the 4th. Sometimes my math lab will want you to have only positive exponents. All right, simplify this one. Okay, so I've got something in parentheses to the 5th power, so I can do each thing independently to the 5th power. Cube root of x to the 5th power. So let's see, 2 to the 5th is 2 times 2 is 4, times another 2 is 8, times another 2 is 16, another is 32. So 32. And then that's x to the 5 over 3. Cool. We'll just keep trucking along, do number 3. Okay. Simplify 49x squared over 36y to the 4th. So, let's see. 49 is 7 times 7. Then I have x times x. And then I also have 6 times 6. Ooh. Y times y times y times y. So actually, a cool trick I could do here is I could rewrite this as 7 squared, and then the x squared as before, over 6 squared, and then y squared squared. So right, I've got a y times a y, so I could write that as y squared squared. So then I could think of that as 7x over 6y squared, all of that squared. So that's a little simpler. Final answer there. Okay, keep on going. Circle which one is correct. Okay, 3 to the 8th equals 6,561, or 3 to the 8th equals 24. So actually, I know this is wrong because 3 times 8 is 24, so it's got to be this one. Okay, 4x to the negative 2 is 1 over 4x squared, or 4x to the negative 2 is 4 over x squared. So actually, the right answer is this one. People get this wrong a lot. So it's this negative 2, there's no parentheses around the 4x, so that negative 2 is only applying to the x. So the 4 needs to stay on top. It's just got a power of 1. So the right answer is the right side. Number 6. X to the negative 2 over w to the negative 4th equals w to the negative 4th over x squared, or x to the negative 2 over w to the negative 4th equals w to the 4th over x squared. I think it's this answer, but let's just do it in a couple steps to make sure. Okay, I can bring the bottom to the top by changing it from positive to negative, the exponent. So that's x to the negative 2, w to the 4th. And then I can bring the x to the negative 2 into the denominator by getting rid of that negative exponent. So w to the 4th over x squared, which, yeah, is the second one. Cool. 7. Use the properties of exponents to simplify the given expression to the form 2kx for some constant k. Interesting. So I want it to be in the form 2kx. Okay. So I think the first thing I would do is so I know that the number 8 is 2 times 2 times 2, right? 2 times 2 is 4. Yeah. So that's the same thing as 2 to the third. So I would rewrite this 8 equal 8 to the 5x over 3 as 2 to the third, and then 5x over 3. And then we know that something to a power, I can just change that to multiplication. So that would be 2 to the 3 times 5x over 3. And the 3's would cancel, and I just get 2 to the 5x. So it's in the right format now. You're probably wondering, like, why would I ever need to do that? And the answer will come later, why you would ever need to do that. So let's see how long I've got left in this section. Okay, quite a bit. Okay, I think I'll just finish. Let's see. Yeah, let's just finish this number 7, and then we'll quit and take a break. So for this one, I would start by combining. So I've got 2 to a power times 2 to a power. So that would be 2 to the 5x plus negative 2x. And all of that is to the 1/3 power. So 5x plus negative 2x, that's just 3x. To the 1/3 power. And if I've got 2 to a power, I can just multiply instead. So 3x times 1/3, which is actually just 2 to the x. So k in this case would be 1. Okay. All right, part C. Okay, I need it to be 2 to a power. So 4 is the same thing as 2 squared. So I'd do 2 squared, just a substitution, x to the 5th. And then 16 is, so 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is the same thing as 2 to the 4th power. And to keep it the same, I need 5x over 3. And, yep. Okay, so now I can multiply. So I've got 2 to a power, twice actually. So I can change that to multiplying. 2 to the, let's see, 4 times 5x over 3. Okay, simplifying again, 2x over 5 times 4 times 5 is 20, so I get 20x over 3. And then when you have 2 to a power times 2 to a power, you can add the exponents. 2 to the 2x over 5 plus 20x over 3. And this is a fraction question, so I'll just do that here. 2 over 5 plus 20 over 3. 15 is a good common denominator. So 6 over 15. And then 100 over 15. So 106 over 15. So that gives me 2. And then to the 106th over 15x. Phew. Okay, D. So this one is going to be a little weird because 3 isn't a power of 2, but I'm thinking that since I have something to the x power over something to the x power, I think I could rewrite this as 12 over 3 to the x power, and then 12 divided by 3 is 4, and 4 is the same thing as 2 to the 2 power, and I just learned that I could rewrite that as 2 to the 2x power. So with problems like these, there's like an element of creativity to these, where you just kind of use those rules at the top, these rules, and kind of aim towards something and just try different rules until you get there. Another trick that you may have noticed is that you kind of get to know the powers of 2 and substitute powers of 2 in. That's very helpful. Any questions on that, you could totally ask them on the discussion board.